I want to talk about independent events and then something called the at least one principle. So here's an example. The probability of flipping a head when you flip a coin is 0.5. Now suppose you flipped 5 heads in a row. What's the probability that the 6th flip is a head? Well, the fact that you flip 5 heads in a row doesn't matter. The 6th flip is what they call independent of the other 5 flips, so the fact that you flip 5 in a row doesn't matter. The probability the 6th flip is a head is still 0.5. I think they have a question in the homework like that. Okay, now I want to talk about what's called the at least one principle. Okay, so let me start with an example using a set of equally likely outcomes. So, of 2 coin flips, find the probability of at least one tail. Okay, well, we can do this by writing the set of equally likely outcomes, which is head, 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 tail, tail, head, tail, tail. And notice how many of these have at least one tail. This one, and this one. These 3 all have at least one tail. And so by the relative frequency of the set of equally likely outcomes, it's 3 out of the 4 total. So the probability of at least one tail is 3 out of 4, or 0.75. Now I want you to notice that what's left over that's not included in the subset of at least one tail is the head-head. So the head-head is the complement event. And I could also do it this way. Probability of at least one tail is 1 minus the probability of all heads. And that's 1 minus the probability that they're both heads is 1 out of those 4. So that's 3/4. That's also 0.75. So one way or another, we get an answer of 0.75 for at least one tail out of 2 flips. But if we were doing more than 2 flips, it would be cumbersome to write out the space of equally likely outcomes, so we can apply what's called the at least one principle. Here's another example. A coin is flipped instead of twice. Let's say the coin is flipped 7 times. Find the probability of at least one tail. Well, we're going to use the rule of complements. The probability of at least one tail is 1 minus the probability that they're all heads, which is 1 minus, now the probability of getting one head is 0.5, and then we're flipping the coin 7 times, so the probability that all 7 are heads is 0.5 multiplied by itself 7 times. 1 minus 0.5 to the 7th power, which on the calculator, 1 minus 0.5 raised to the 7th power, that gives me 0.992 to 3 decimal places. Now, one more example of this. Suppose, instead of having a fair coin, suppose we had an unfair coin. So instead of the probability of flipping a head was 0.5, now suppose probability of head on a flip is, say, 0.532, so it's not a fair coin, but we can still apply the same principle to answer the question, find probability of at least one tail in 5 flips. So by the at least one principle, it's 1 minus the probability that they're all heads. And that's 1 minus, now the probability of getting one head is now 0.532. And there's 5 flips, so the probability of all heads is this 0.532 multiplied by itself 5 times. And on the calculator, 1 minus 0.532 to the 5th, 0.957 to 3 decimal places.